I wanted to start by showing you how to do the homework for day 4. This is coming from page 127. That's 5-3 practice from the workbook pages. 1 through 4, you are solving by factoring a special pattern called the sum or difference of two cubes. Now the first thing you need to know is, what are perfect cubes? Well, just like perfect squares are 4 or 9, 16, 25, because when you square a number, the answer you get is called a perfect square. In the same way, if you cube a number, the number you get is called a perfect cube. So 2 cubed means 2 times 2 times 2, and you get 8. So 8 is called a perfect cube. 3 cubed means 3 times 3 times 3. 4 cubed is 64. 5 cubed is 125. And 6 cubed is 216. This is a good list of perfect cubes that you ought to know. I would write these down somewhere for reference in your notes, okay? Because you'll definitely use those on this homework. The other thing you need to know are these special patterns. It's the sum or difference. Sum or difference of two cubes. And let me tell you these patterns. Okay, the first one is the sum of two cubes. So if you have something cubed plus something else cubed, you can factor it into a plus b times a squared minus ab plus b squared. And the best way to learn these patterns is just to look at examples, which we will do as I go over the homework. But you need to jot these down. You need to have these written down somewhere so you can reference them as I go over the homework. So be writing these down as I write them down, if you would. So the next one is the difference of two cubes. So the only difference there is you're subtracting. But pay attention to this next part. Notice I add a b on this one. Okay, and the reason that is because if you want all these middle terms to cancel, if this is plus, then this needs to be minus, so that'll cancel. And the reason this is plus is because that will be plus. Okay? In the same way, if you have the difference of two cubes, you start by subtracting a and b. But again, I want all those middle terms to cancel, so if that's subtraction, this needs to be the opposite to make them cancel. So keep a note of that. Okay, so now let's go over the homework. First of all, we'll do number 1. You will notice it is the difference of two cubes. The reason I know that is because 8 is a perfect cube, and x cubed is a perfect cube, and 27 is a perfect cube. Now the first step anytime we solve a polynomial equation is to set it equal to 0. You will notice these first 4 problems are already done. Okay, but what we need to figure out here is, what is the cubed root of 8x cubed? Okay, and the answer to that is, well, what's the cubed root of 8? That's 2. And what's the cubed root of x cubed? That's x. So if you refer back to where I wrote down that pattern of the difference of two cubes, I had a cubed minus b cubed. Okay, so then A would be 2x and B would be 3. Okay, and the rest of it, if we follow the pattern, it was to do A squared, so that means 2x squared, which gives me 4x squared, plus A times B. Okay, so that'll be plus 6x, and then plus B squared, and if B is 3, then B squared is 9. Okay? So, from here to finish solving, we use the zero product property, meaning that after I factor it, if I take both factors and set them equal to 0, I can solve for x. Okay, now the first one is really easy because it's linear. You add 3 to both sides, and then you divide by 2. So one of your answers is x equals 3 over 2, or 1.5. It's the same number, whether you do it as a fraction or a decimal. Okay, that's one of your answers. Now to figure out this one, you have to think about factoring. Okay, but the thing is, whenever you solve the difference or sum of cubes, you're always going to have one real answer, which is this 3 over 2, and then you're going to have two imaginary answers. And that's what we get from this quadratic equation. I know it's a quadratic because of the x squared. So one easy way to solve any quadratic equation is to use your calculator, go to the Algebra 2 program, and enter A is 4, B is 6, and C is 9. And when you do that, you should see that the answers are -3 plus or minus 3I square root of 3 all over 4. That's what your calculator gives you. And notice I said answers, because the plus or minus gives me two different answers. Okay, so you really have 3 zeros here. You have one real 0, which is your 3 over 2, and then you have 2 imaginary zeros, which come from your program. Okay? So if you need to write that down or process it anymore, you can pause the video. On to number 2. You'll see that number 2 is different because it is the sum of two cubes. You have x cubed plus 64 equals 0. To solve this, we're going to factor it using our special pattern. So the cubed root of x cubed is just x, and the cubed root of 64, if you look at your chart from the notes on the first slide, that is 4. Okay? Now, if you remember, the rest of it is the tricky part. We do x squared, and then we do minus, because we have to do the opposite to get them to cancel. A times b. In this case, that's 4 times x, so 4x, and then plus b squared. If b is 4, that's plus 16. Okay? Now apply the zero product property. If x plus 4 equals 0, when I subtract 4, I get -4. There's my real answer. If you remember, this one gives me my two imaginary answers. So if we go to our calculator in the quadratic program, a equals 1, b equals -4, and c equals 16. When you put that in, here's what we get. X equals 2 plus or minus 2I square root of 3. So again, just like in number 1, here's my 1 real answer and my 2 imaginary answers. Okay? Alright, so if you need more time there, you can pause it. I'm going to move on and show you number 3. Number 3, you will notice on number 3, neither one of these are perfect cubes. 2 is not a perfect cube, and neither is 54. Okay? But the first thing I want you to think of, anytime you're solving a polynomial, is there a common factor that you can divide out? And in this case, I can divide out a 2. So if I divide both sides by 2, I'll be left with x cubed plus 27 equals 0. Now I have the sum of 2 cubes. So when I factor using my pattern, I get x plus 3. And then applying the rest of the rule, x squared minus 3x plus 9 equals 0. Okay, apply the zero product property. If I set x plus 3 equal to 0 and solve, I get x equals negative 3. If I set this equal to 0, I'll go to my Algebra 2 program, enter my A, B, and C, and I'll do that now. And my other 2 imaginary answers are 3 plus or minus 3I. Don't ignore the I because that's what makes it imaginary. All over 2. So, 1 real answer and 2 imaginary answers. And then we have number 4. I know what you're thinking. Just like in number 3, 2 nor the number 250 are perfect cubes. But, just like in number 3, what can I do? Anybody? Good. Divide everything by 2. That'll give me x squared minus 125 equals 0. And if you look back at your list of perfect cubes that I gave you at the beginning, I made a mistake. If you look back at the list, 125 is a perfect cube. And this is the difference of 2 cubes. So I get x minus 5. And then the other part is x squared plus 5x plus 25 equals 0. Set each one equal to 0. For this one, I would add 5 and I get x equals 5. There's one of my solutions. The other one, I will use my calculator, Algebra 2 program. And I get x equals negative 5 plus or minus 5I square root of 3 all over 2. So that's 1 through 4. Okay? If you have any questions, don't forget, you can email me. Okay? Good job.